So I just got back from an amazing trip. I was visiting Rotterdam in the Netherlands, where I was invited to give a speech about science education at an awesome conference hosted by Shell. I talked about how we need to make science education fun, and to make some of my points, I played rock and roll piano up on stage. I think people really enjoyed it. I had a great time. But one of the coolest parts was that they set up essentially an entire science museum about energy and how we use it. After I gave the talk, I got to hang out at the Energy Lab with some really cool kids who'd been invited to be participants at the conference. So I want to show you some of the stuff we got to mess around with and explain a little bit of the science behind these really cool demonstrations.
You're not going to get any brain damage. Just step on that. Great. Now here I am at the Shell Energy Lab in Rotterdam. And we're looking at an amazing static electricity demonstration. Her hair is coming apart like this because it's losing electrons. Electrons are moving from her hair and from her body into that big metal ball. And because of that, her hair is getting a positive charge, and all that positively charged hair wants to move apart, which is why it's becoming huge, why the strands are trying to separate and get as far from each other as possible so that that same charge, that positive charge, can move out. So this is a great example of static electricity, which happens when electrons move from one thing into another. It creates positive charge in one object and negative charge in another. Static is a word for standing, and so that's exactly what's happening. We have these charges that are standing, they're stuck in place, and that's why the hair stands on end. So, we're going to go back to the lab in a minute. I'll show you how the charges are actually being created in this generator called a Van der Graaf generator. We'll talk about how the metal sphere here is a machine for sucking electrons out of the metal and also ultimately of the body or the hair of someone who's touching it.
So what we just saw is called a Van der Graaf generator. And what it does is it makes a large amount of static electricity. Here's how it does it. There's this metal sphere, which you saw in the video, but what you probably didn't see is this other stuff. There are two rollers, and then there is a rubber belt that moves between the two rollers. Now, up here on this top roller, electrons are moving into the belt. The top roller is able to give up its electrons to the belt. Okay, so the belt down here is going to become negatively charged. So this charge moves down because the belt is moving in this direction. Then when the belt with a negative charge gets to the lower roller, the charge comes off of the belt and accumulates on this lower roller. So it gets really negatively charged here. Then a lot of this negative charge makes its way down to the ground, and that's how we get rid of it. But anyway, we've taken a lot of this negative charge off the belt at the lower roller, which means that as the belt moves back up here, it's going to be positively charged, until it gets up here. And we've said before that this roller likes to give up its electrons to the belt. The roller up here is going to become positively charged as it moves its negative charge onto the belt. All right, now this roller can't just become more and more and more positively charged. In order to balance this out, electrons are going to be moving from the metal sphere into the roller area here. And so as electrons get pulled out from here, the metal sphere itself is going to become positively charged. As electrons and negative charge move into the roller, move down the belt, and move into the ground. So that means that this metal sphere is going to become really positively charged. This positive charge wants to spread out. So when somebody touches it, the positive charge moves into their body, and it moves into their hair, making their hair positively charged. Now, things that have the same charge want to move apart. And so that's why the strands of the hair separate and get further and further apart, why they move away like this, because they all have this positive charge that is moved from the metal sphere into the hair. So that's why we see that thing with the hair going on. But basically, it's just important to remember that this generator is a really cool way of moving electrons from this sphere down the belt and down to the ground. It creates static electricity in the process. So we're about to see an example of a direct current generator that we use to race some little cars. A direct current generator like this essentially gets electrons to move along a wire, and the movement of electrons creates electricity. Here's how it happens. There's a coil of wire that's in between the poles of a magnet. And when wire moves in a magnetic field in between the parts of a magnet, it forces the electrons to move along it. So this coil of wire is attached to a handle that will spin, making the coil of wire spin within this magnetic area, and that is going to make the electrons in it move through the coil of wire, creating electricity. Now, a real direct current generator has a few additional parts here, but I left them out because I just wanted to give you the basic idea of how spinning a coil of water in a magnet, in a magnetic field, causes the movement of electrons. Let's take a look at it.
Here's an example of electric current. We're going to be spinning these wheels, which is going to create an electric current that's going to make these cars go. The faster we turn this wheel, the higher the voltage the generator is going to create, and the faster the car is going to be able to go. Creating this electricity happens because there is a coil of wires in the middle of this that moves through a magnetic field. And when a coil of wires moves through magnets or a magnetic field, it causes the electrons in that wire to move. And moving electrons, or what we call electricity, or electric current. So now it's time to have a race. See who can generate the most voltage and make the car go faster. Ready? 3, 2, 1, go! That was second.